Morning everyone, my name is James Coe. I'm the Internal Sales Manager at Kensa Heat Pumps. We're a UK ground source heat pump manufacturer, the leading UK supplier of ground source heat pumps within the UK. We offer design and supply systems to our customer base across the whole of the UK, and also provide support with regards to ground array design and also an installation service through reputable installers.
Hi, I'm Steve Costello with Hex Energy, just to the left there. We're a company that specialises in renewable energy of all types, specifically ground source and air source heat pumps.
Three of your four panellists are really on the heat pump side of things, but that is not the only way to heat a building. What are the options for heating a building? Well, of course, you've got your air source and ground source heat pumps. Can I just pause there? So, an air source heat pump is drawing its heat in from the air. It's got a fan to help it do that. A ground source heat pump takes its energy from the ground. We're not talking about geothermal energy here. This is simply ground that is heated every year by the sun. It is really solar energy that we're using when we talk about ground source heat pumps. And then there's biomass boilers. Biomass is having a bad press at the moment because all the kind of moralistic types, well, you mustn't burn wood. Man has been burning wood since the dawn of time to stay warm. There's nothing wrong with wood as long as you manage it and use it sustainably. Then you've got complete house systems, heat pump ventilation systems, sort of think Clarissa's involved with. Little stoves that many of us use to keep warm in individual rooms. You've also got the choice of oil and LPG. Oil and LPG need not mean hydrocarbons. It could be bio-LPG, it could be biodiesel. You've got green options starting to come on board. And then of course, solar water heating, which is genuinely free, zero carbon heating. Right at the start, you see gas boilers. The gas network itself is decarbonising. We're starting to put hydrogen into it, in places up to 20%. Things change. If you're, for example, building new or retrofitting, you've got a different set of questions you're asking about your heating system. If you've got mains gas, that makes a difference to the decision-making process. We've got four very knowledgeable people here, four experts, in fact, in their respective fields. What are the burning issues? What is on your mind?
We have a build project with an extension. The current heating system in there is a warm air system, which is quite old, probably about 40 years old. It's gas fed. We're looking to see what the best options are to replace it. Or do we stay with a more modern version of the warm air system?
It does depend on the size of the property and the building fabric, what's going to be appropriate to go for, because unfortunately, even though you've got a space heating system at the moment, it might not be appropriate to put a different unit on the end of it if you can't stick with something like gas.
I think as well what you have to do is look at exactly what the disruption is going to be in your building when you change things, because with your ducting that you've got for your warm heating system, you will need to be putting in pipe work all over the house for the new emitter circuit. Don't put in very, very thin pipes because you can't carry the heat in low temperature heating. So microbore type pipes are not compatible really with low temperature heating. But you need to look at how much insulation you've got in that building. And can it actually keep you satisfied at a temperature you want to be at the types of temperatures that it wants to work at. So get the insulation and the draft proofing absolutely spot on. And if you're going to get rid of those ducts, you need to close them up. It's not okay to put ventilation heating into that because you haven't got enough ducts as well. It's not hot enough.
Also extracting stale air out of kitchens and bathrooms, and your space heating system won't be doing that. It will only be supplying air in, and you'll need to have trickle vents and extractor fans, because if you're sealing up the house that much more as well, the air has got to go somewhere. So depending on how far you're going with the renovation, will probably help you make a decision on what's going to be appropriate.
I think at the moment you're talking about a distribution system, and a warm air distribution system. It used to be
be installed in quite a few properties back in the 70s. Some of them were very, very good, some of them weren't so good. The actual heat source that you've currently got is a gas boiler, and I don't see any reason why we couldn't change that for a ground source or an air source heat pump. The actual heat source is only relevant in regards to how much energy you need to put into the house and how well your current system distributes that energy. So you'd need to do a survey and see whether the heat distribution system you've got at the moment would work at the temperatures that we could deliver from a heat pump. But if you were going to increase the insulation value of your property at the time when you do this renovation, you are going to reduce how much work that system has to do and make it more liable to work with a heat pump. And to be quite honest, if you're going to do a retrofit of a system, spending money on the insulation is going to save you pounds on the running cost, and should be the first thing you do before you even look at the technology you use to put in there. So with today's energy prices, save the cost, put some insulation in, and then talk to specialists and find out whether you can use what you currently have.
Could you talk a little bit about underfloor heating benefits, challenges, and specifically from the eco side of that?
It's probably going to be also the expert, but I've got a bit of background on that one. Underfloor heating, you're basically looking at a large surface area in comparison to other heating emitters, such as radiators. Certainly within ground floor solutions, within a screen, you can bury the pipework within the floor fabric, so you don't actually notice that. It's a much more comfortable heat as well, it's a lower temperature, but that larger surface area, at that lower temperature, that heating solutions work, such as heat pumps, that's where you actually benefit from more efficiency with those sort of solutions. Heat pumps as a whole, they will work with either radiators or underfloor heating, but of course it's that sort of element of larger radiator sizing required. It's purely just for the fact that we are looking at operating heat pumps at a lower temperature as possible to maximise their efficiency.
With underfloor heating, your biggest thing you're going to look at with that is designing it right in the first place. You want to have a small amount of heat over a long period of time with underfloor heating. It's not highly reactive. So when you start engineering it, are you engineering it for the two different types? Are you going to have a screen, or are you going to have spreader plates? Because you're going to have slightly higher temperatures in the spreader plate system. But what you've got to be careful of is what you've got on top of it. You don't want it to be too hot, because then it could discolor anything that you've got that might be a modern vinyl type of solution. You start getting pink lines in it, or it could crack your tiles as well if it's not done right. But make sure that you're happy with a low temperature heat for a long period of time. My wife was scared to put it in the lounge, and she now wants to know why we didn't put underfloor heating in the rest of the house. So it's something that once you've got it, you love it. But you've got to know that it's not that quick spin the dial and heat up the room.
And that's a big challenge if you've got an existing building with no insulation. It's very, very difficult to retrofit underfloor heating. A lot of people come to see me and say, we're doing an extension. Great. We can put the underfloor heating in there, and you're still going to use radiators in the rest of the house if you're switching over, let's say, to a heat pump. Next question.
I just wanted to add one thing to that. If you're future-proofing, if you start off with a boiler, make sure your underfloor heating is designed for a heat pump. You can blend the boiler cooler, but you can't make a heat pump hotter without losing a lot of efficiency. So make sure it's designed for a heat pump to run at those very low temperatures.
I'd like to add a few comments. Unfortunately, I'm old enough to remember when underfloor heating first came to the UK 20 odd years ago, when it was first being talked about. And initially, when I first heard about it, I thought it was a bit of a nonsense, because in the UK we tend to heat things up fairly quickly and expect the heating system to react within 10 or 15 minutes of turning it on, and then we like it cooling down at night. And underfloor heating doesn't react that quickly, but as the building envelopes in the UK have become more efficient, actually maintaining that heat input to keep up with the heat loss is the smart way of doing it. When you look at retrofitting it, what you need to consider is that underfloor heating has a limit to how much energy it can put into a room. Certainly David mentioned about overheating the floor can be problematic for the floor finishings. It's also not good for the health. I mean, too hot a floor can give you deep vein thrombosis, so you don't want to run your floor hot. So You shouldn't be walking on it thinking this is nice and toasty. It should be delivering background heat without like walking on a hot plate. And because of that, if you're in a really old drafty house or a listed building, underfloor heating might not be man enough to heat the space on its own, and you may have to use some other form of assistance like fan-assisted radiators or just normal radiators. So again, if you look at the fabric first, certainly with renewable technologies, one of the first things you'll have to do is do a room-by-room heat loss calculation to figure out what each room in the property loses as regards energy, and that will tell you exactly how many kilowatts each room needs to be heated, and whether underfloor heating will work in that, and more importantly, what spacings you will need to use on the underfloor heating pipe. So, as a hierarchy, you want to actually figure out what your room-by-room losses are before you start getting a design, and not getting a design and then trying to apply that to a house or a technology you're going to use. So, make sure you get the process.
As we get better and better at producing buildings that have a very low heat demand, especially I think we're talking about new buildings here, probably at least half of you are looking at building new. The importance of what we call domestic hot water, the water we use for showering and bathing, doing the washing up, becomes relatively greater. It will be a relatively larger proportion of your total heating bill. So I want to ask the panel for their individual views on what kind of technology is best for providing domestic.
It depends really what else you're going to have in your house. Very good technology that's very energy efficient is an air-to-water heat pump, which basically utilises an air source heat pump on top of, say, a 300-litre tank of water, and the refrigerant in there is very efficient at the higher temperatures that you need for the water coming out of your taps. And the beauty of it is that it sits in your utility room. It's not something that's outside, which means that if you're a bit short on space outside, and love them though I do, air source heat pumps, they do make it obvious. And in the summer months, you don't really want an air source heat pump near your patio where you're having your barbecues and things like that. So having a unit inside the house that's very quiet, producing the water that you need year round is actually quite a cunning thing to have above an air source heat pump. You can still have an air source heat pump to go on your underfloor heating. You're keeping the air source just to do your heating. I mean, it's not on in the summer months. You're not going to be disturbing your social time. It does have to be near your barbecue. And conversely, your neighbours as well, if you do have them close by.
I think it very much depends on how much hot water you're actually using as well. If you're using a lot of hot water, you might find that your hot water demand in your house could be higher than your heating demand in your house if you've got a very efficient passive house type construction. So then you're going to start looking at your technologies. And as Clarissa says, there's different types of heat pumps that you can use. So if we start having a higher temperature demand for hot water, we start using different refrigerants like CO2, which is known as R744, makes a very high temperature. It's not hugely efficient, but it's very good at high temperatures. The small units that Clarissa talks about, I've got one of those in our own house where we've got it on top of the hot water cylinder, simply because we didn't want the outdoor unit to run during the summer months. We didn't want to hear it, so it doesn't run at all. We've got the heat pump attached to the hot water cylinder. That's got a different refrigerant that's called 134A, and it operates at a higher temperature as well, but it needs a higher input, so it likes the fact that it's taking stale air from inside the house to make hot water. So it does very much depend how much hot water you're making. If you've got an efficient house, you only have one or possibly two people in that very efficient house, maybe storing the water doesn't make sense. Instantaneous hot water, even with a fossil fuel, might still be the most environmentally friendly thing because you're not wasting anything. So I think analyze what you want to use first and then start looking at different technologies, because one size doesn't fit all.
I'm hearing two things here that I need to challenge the whole panel on. First, nobody's mentioned solar water heating yet. Now, solar water heating is free heat. Yeah, you're only going to get 6 months of the year, but it's free heat 6 months of the year. That, if you want to keep it quiet for the barbecue, that's your best option. Actually, heating. And secondly, there's a faint suggestion from David there that actually, in some cases, fossil fuels might be the most sustainable approach to heating. Now, that's against the accepted wisdom. How would Kensa respond to that?
Solar thermal, there are two principal differences there, and you can identify quite easily on houses. Some people will have a huge array of panels on their roof. That is going to be likely to be PV. When you look at solar thermal, you're probably only going to be talking about 1 or 2 panels. The benefit of solar thermal is that it can tie in with any technology, even air source or ground source technology. The benefit of a ground source solution is probably one of the most efficient ways of providing heating and hot water throughout your property. David sort of already touched on the volumes required. You would ask somebody to obviously undertake a design on the property to make sure the usage fits with the client's requirements, but also the property's requirements as well. One thing to just consider is if you had 2 people living in a 4 or 5 bed house, you would still probably design a larger cylinder, because should those people sell the property and the family of 6 move in, that's going to be very much undersized. If it was undersized, if it was just designed for the 2. But going back to the solar PV and ground source provide the heating and hot water all year round. The benefit of adding something like solar thermal to the property is that what we do, it means that you'll be providing all your hot water for the majority of those warmer months and summer months, which would mean that your heat pump won't need to operate at all. Because obviously your heat pump will still operate in summer to provide that hot water requirement. Obviously, if you can eliminate that with solar thermal. The other way to look at it is tying solar PV, and you can also speak to a control specialist. The PV can actually charge the immersion heater and hot water cylinder. So there's lots of different ways of adapting your systems required. But I think we've all talked about it. It goes down to designing and the installation. Speak to renewable technology suppliers, and just make sure that everyone is understanding the requirements. I'd like to say, I think hot water requirements have been around since I was a boy, so I think if we look at how we currently do hot water, I mean, I have a gas combi, but if you look back at the birth of the gas industry, most of it was stored hot water in a hot water cylinder, and if you've got a hot water cylinder off a gas boiler, it's probably stored at 60 degrees C. Back in the early 80s, combis came into the market and instantaneous hot water became the norm, and now that's what 70% of the gas boiler market is. I think when you look at the renewable technology, none of the heat pumps, ground source or air source, are actually able to give you that combi type facility. They cannot give you instantaneous hot water. So we have to revert back to the stored hot water. Really, then the choice is down to the customer. Do you want to have high levels of hot water? If so, you're going to have to heat it to 60, 65 degrees like Kensa would in your stored hot water cylinder. And then you can blend that down to sort of 2/3 of what it wants. So 300 litre cylinder is going to give you sort of 450 litres of usable hot water. Or the alternative is to store the hot water to lower temperature, allow it to be more efficiently manufactured, and but it gives you lower amounts, and size the cylinder accordingly. So a lot of it comes down to what you want as the customer. How big's the cylinder you're happy to have? What's your water usage? We can work that out from the number of bedrooms and things like that and give you an idea. But it's always interesting to find out what the customer's requirements are. And
Steve, tell us which is going to be the cheapest way of heating, providing hot water.
Okay, I think in reality the government has already set the agenda. By 2035, they've already said that they don't intend to sell any more gas boilers. So whether we realise it or not, we are all faced with the fact that we're either going to have to heat our homes electrically, directly electric, or we're going to have to look at renewable technology. And realistically, air source and ground source heat pumps are the best options of maximising your electricity. So both of those technologies are going to give you between 3 or 4 times more energy per kilowatt as if you're just using it directly. So that's the reason why the ground source and the air source market is so buoyant.
Let's just clarify that word directly. Okay? What he means by directly is if you remember the old-fashioned 3-bar electric fire, that simply takes electrical energy and turns it into heat energy. That is not what a heat pump does. A heat pump will give you, let's say, 3 units of heat for every unit of electricity you put in. Your 1-bar coal-bar electric fire gives you 1 unit of heat for 1 unit of electricity. So your heat pump is 3 times more efficient, 3 times less on the cost. Okay. James, how does that compare to a gas boiler?
At the moment, when you look at fuel bills, everything it's very much a concern for everyone at the moment. If you look at the cost of gas in the comparison to electric, you are probably looking at electric 3.5 times the cost of gas. From a direct comparison, obviously if you looked at the ground source heat pump with a COP of 4, so 400% efficiency, then you can quite easily argue that the ground source heat pump obviously costs a lot less than a gas boiler. The first thing to consider is that initial infrastructure investment. So with ground source, obviously it's very comparable with air source for the initial plant cost. But of course, you do have that additional infrastructure for your collector array that you need to allow for. I think ground source technology or heat pumps as a whole, they are the future, as Steve said. We're going electric. It's going to be for yourselves, it's about how you design your infrastructure around it. It's not just going to be a heat pump, you're probably going to incorporate solar PV. The other thing to talk about is electric vehicles. I don't even touch on the price of fuel at the moment. But if we have solar PV, you can generate your own electricity, and battery storage, store that. That's not my area of expertise, but you can store that to actually generate the electricity required to charge your vehicles, to provide all the heating and hot water. That is going to be the only way that we're going to be, I think it's going to be going. It's whether the government will potentially subsidise the electricity cost against fossil fuels later on. Remains to be seen.
Okay, so before I let David speak, switching from gas to heat pump might save you a little bit, not a huge amount at the moment. David?
The cost of gas on the price cap at the moment, some guys might be in tie-ins, the cost of gas is about 7.3p per kilowatt hour, and the cost of electricity is just on margin over 28 pence per kilowatt, depending on who you signed up with, and depending on what type you take that energy as well, because there are some companies that give it to you cheaper at certain times of the day, but then it's going to be more expensive at other times of the day. So you've got to work out when you use that energy. As far as I'm concerned, we know 3 things: death, taxes, and the rise of fuel prices. But what we should do is try and avoid using the energy in the first place. So as far as I'm concerned, insulation, and draft proofing, and then on top of that, start working out how do I manage the heat in my home. At the moment, we all have thermostatic radiator valves, which in my mind are useless. They give you an indication of which way to turn them, but they don't actually give you an accurate idea of what the temperature is in the room. So I would be putting motorized radiator valves in as a start. If you're changing your home, then look at electric ones that are not motorized in the room, but managing the home so that you know if a room needs to be at 17 degrees, you set it at 17 degrees. 21 is 21. Turn the room off, whatever you want. You can get that other device run by Amazon to start running it for you as well if you need to. But as far as I'm concerned, you need control in the home. And the best money you're going to spend right now is on not needing heat. That would be my way forward.
We're back to insulation, reducing heat demand, and we're back to heating controls, both really, really important. So we're talking about cost, that's where the question started. Clarissa?
Well, David stole my thunder there. I was going to say that very thing about allowing as much of your budget as possible into the fabric of the building. The more you spend on creating a tea cozy effect on your house, the less you're going to have to spend on heating it. I think, though, that you can't really suggest one particular type of fuel is going to be the best going forward, because it really does depend what sort of property you're going to heat, how big it is, whereabouts in the country it is. I mean, when we were talking about gas being cheaper and things like that, in the future, you might be able to replace your gas boiler with a hydrogen boiler, but that's, it's not one size fits all. As David was saying, unfortunately, hydrogen is very costly to produce. It's great for the atmosphere, but it does take quite a lot of electricity to separate out all the elements from the water. Now, if you're
very much, Chris. I'm hearing that it's very much horses for courses. Question here, just while we're getting over to take that question. Small townhouses probably going to be very difficult to retrofit heat pumps into. Gentlemen, just here.
About a week ago, I read about grass being used to create gas for domestic use. Thoughts about that?
So we're talking about green gas. There's a lot of moves saying that the government's building strategy, which is entirely based around electrification, the move over to heat pumps, might not be the optimal way to go because it's going to require massive reinforcement of the local grid networks. We don't have enough renewable electricity at the moment to support complete electrification. So why don't we decarbonise the gas grid? David, can I start with you on this?
The gas grid is getting decarbonised. We're getting three different things going into it. We're getting hydrogen first, which a lot of the time makes it easier to store energy seasonally, simply because we're using the electricity from wind farms and solar farms to just change water into hydrogen and store it. We're also getting synthesis gas, which is the extraction of gas from anything that's not metal or glass. So you will have big bags, including plastic, that can be incinerated at high temperature. You will then get synthesis gas from that, and that gets put into the grid, and also anaerobic digestion from that grass, where that is happening a lot on farms, and the low-grade gas can be burnt and turned into electricity anyway. But it's all happening. But there's one central thing on that: it all costs money. So when we start getting all these alternatives, it's great to think, fantastic, I don't have to get rid of my gas boiler, but the cost of gas is going to rise faster than the cost of electricity based on that. So it might be fine now to have a gas boiler, but in the future, it's 4 times cheaper to run than electricity. But in the future, we're going to start having a gas boiler that might only be half the price. So suddenly heat pumps then become magnificent solutions. So it's all about what's going to happen, what if. And we're relying on the government to do things, and it's a government that seems to like to party. So things swiftly on.
We all like to party, but I think this question about green gas is really important. David touched on something there about how we produce hydrogen. Larissa mentioned that it takes electricity to produce hydrogen. What's a zero-sum game? Why create electricity and then use it to make hydrogen? But we do get spikes in our renewable energy production. We get times when the grid can't cope with what PV puts into it. Use that excess energy to make hydrogen, because all other forms of storage they're either really, really inefficient or they go off over time. Heat dissipates. Potential energy, your efficiency losses are enormous. But hydrogen is a very good inter-seasonal source of energy storage, which batteries are not. People come to me and say, I'm going to put in PV in a heat pump, I'm going to be carbon neutral. Oh no, you're not. Because that heat pump is needed in the winter, and the PV is producing in summer. The average size of a domestic battery storage system is such that that won't get you through more than about 24 hours. It won't deal with the inter-seasonal question. Hydrogen, just about right. Another question over here. Sorry? We've run out of time. I didn't know we'd run out of time. Are you ready to come in? Ladies and gents, thank you for some excellent questions. And can we give a thanks to our